Analysis of variance is probably one of the most commonly used statistics in science. So we now are going to show you how to run a factorial ANOVA in SPSS.
Here's our design. We have two independent variables, sex, obviously with 2 levels, and group with 4 levels. One group received a pedometer only, another group received a pedometer and written support, the next group received a pedometer and personal support, and the last group received a pedometer and personal and computer support.
The dependent variable is going to be steps taken per week. There will be 50 people in each group, 25 males and 25 females. Each cell then will have 25 people in it.
Here's the variable view of the data setup. Notice we have sex, group, and steps per week. So we'll run an SPSS two-way ANOVA and provide the results for you. Here we'll provide the results and walk through them. Then we'll show you how to run the SPSS two-way ANOVA.
The first part of the output you would look at to make sure that you've got your subjects entered correctly.
Notice we have a grand total of 200 subjects, 100 males, 100 females, and then 50 in each of the 4 groups. The next piece of the output provides descriptive statistics by gender and by the 4 levels of group.
You can check the means for the 4 groups of females, the 4 groups of males, and then for the combined groups.
Notice there are 25 individuals in each of the groups. We'll now look at the F-tests. Recall that there will be 3 F-tests, one for sex, one for group, and one for the interaction of sex by group.
The F-test for sex is not significant.
Here's the ANOVA source table. Notice there are a number of things listed here. The corrected model, the intercept. The key things that we're looking for are the lines associated with sex, group, and sex by group. Notice that the F value for sex is 0.281. The P value, or significance level, is 0.596. There is no significant difference in the number of steps reported for the males and the females. In this analysis, it disregards into which group you fall. It's only looking at the differences between the 100 males and the 100 females.
The F-test for groups, however, is significant.
Returning again to the ANOVA source table, let's look at the line associated with group.
The F is 14.8. P-value, or significance, is 0.000. If you kept going, there's a 1 someplace. But it is significant. So we're later going to have to come back, because there are 4 groups, to see where the significance is.
We'll do a post hoc procedure, as we've described in the past. The third F-test is for the interaction. Is the effect of the grouping variable constant across the 2 sexes? Again, now we'll look at the line for sex by group. And we see that it is not significant. Oftentimes you don't want to have a significant interaction, because then you can't talk about one level of a factor without talking about the other factors as well. We've also plotted the results of the interaction. Even though they weren't significant, we simply want to illustrate what the interaction plot would look like. Notice on the horizontal axis we have the 4 groups, and then each male and female group is mapped separately. Notice how close to parallel the lines are. Regardless of which group you're in, you'll see that there's commonality for the males and females. The interaction was not significant. Recall that there was a significant group effect. So let's go look at some post hoc procedure.
We use the student Newman coils here again, and as we've seen before, it puts the means into subsets. Any means that are in the same subset are not significantly different. For this output, we found that the pedometer group does not differ from the pedometer and written support group. The pedometer and written support group does not differ from the pedometer and personal support group. The pedometer group differs from pedometer and personal support group, and the pedometer, personal, and computer support group differs from all 3 other groups.
So you might think, if you were conducting a study or an intervention, to try to get people to be physically active as assessed by steps per week, that the most impactful way, based upon this research, might be having people receive a pedometer and personal and computer support. We'll now turn to SPSS and illustrate how to conduct this analysis.
Here's the SPSS data view for our SPSS example.
Recall that the model is a 2x4 analysis of variance. We have sex with codes 0 and 1 and groups with codes 1, 2, 3, 4. The dependent variable is steps per week. To run the two-way analysis of variance, we go to Analyze, General Linear Model, Univariate. Our dependent variable is steps per week. Sex and group are fixed factors.
Click on the Options button and move sex, group, and sex by group into the display means for the box and check Descriptive Statistics in the display box. Click Continue. Now click on the Plots button and move Group into the horizontal axis box and move Sex into the separate lines box. Click on the Add button, then on Continue, and then click OK.
Now we have our SPSS output just like we saw in the previous slides. We have here the number of observations in the cell. Then we have descriptive statistics. Then we have the tests of between subjects effects, the ANOVA source table for sex, for group, and sex by group. And then as we scroll down, you'll see we have the plot that we presented for you. All right, we're done. But no, we're not. We forgot. We wanted to do a post hoc test on the grouping variable because group was significant. So we go back into Analyze, General Linear Model, Univariate, and this time we're going to click on Post Hoc. We'll move Group because that's the factor that we want to conduct the analysis on. We'll click on SNK for student Newman coils, say Continue, and OK. We'll get the analysis again, and as we scroll down, we'll find the results for the post hoc procedure student Newman coils as you've seen in the previous slides.